Hey everybody, welcome to video notes here for topic 7.1, Introduction to Air Pollution. We're starting out on page 410. So air pollution is the introduction of chemicals, particulate matter, or organisms into the atmosphere at concentrations that are high enough to harm plants, animals, or to cause harm to buildings or ecosystems. Air pollution is a very large, vague concept that we do not want to use when we're writing on FRQs or speaking like a scholar. It's kind of hippy-dippy talk. We want to refer to air pollutants. These are specific chemicals or particulate matter that have specific sources. They have specific impacts on plants and animals. And so this is what we want to spend our time focusing on. Pollutants, not air pollution as a vague overall topic. So next we have the Clean Air Act. And the Clean Air Act started in 1970, and it named 6 key or criteria air pollutants that the EPA is required to set acceptable limits for and to monitor and regulate. Those are SO2, or sometimes referred to as SOx if we're referring to sulfur oxides as a whole class, so SO2 or just SO. Then we have NO2 and NOx. Then we have carbon monoxide, particulate matter, ozone, O3, and we'll talk about how ozone in the troposphere is actually an air pollutant that is not beneficial in the troposphere down near Earth. And then we have lead. And so once again, the EPA is required by the Clean Air Act to set acceptable levels of these air pollutants and to monitor them. Next we have coal combustion and SO2. So we oftentimes refer to coal as dirty, quote unquote, and we want to unpack why that is and be able to articulate that. So coal is considered the dirtiest fossil fuel because its combustion releases the most pollutants. It releases carbon dioxide, sulfur dioxide, toxic metals like mercury, arsenic, lead, and particulate matter, and carbon monoxide. So it's very polluting in all of the pollutants that it releases. Sulfur dioxide is one of particular concern because sulfur dioxide is a respiratory irritant, so it damages the respiratory tract of plants and animals. It's also something that can lead to sulfur aerosols, which are just suspended sulfate particles, physical or liquid particles, that block incoming sunlight, and this reduces visibility, reduces the effectiveness of photosynthesis. And SO2 is also converted into sulfuric acid in the atmosphere, which causes acid deposition or acid rain. Here is a picture to kind of walk you through that there, give you something to latch onto, something to think about when we're talking about sulfur oxides or sulfate aerosols here that reduces visibility. And you can see people in cities in China where coal electricity production is really high are using masks to try to protect their respiratory systems from those sulfate aerosols. Next we'll talk about fossil fuels and nitrogen oxides. So combustion of all fossil fuels releases NOx or nitrogen oxides into the atmosphere, and this causes a few different impacts. It causes production of ozone in the troposphere, which again is bad. We'll talk about how ozone is beneficial in the stratosphere, but it's actually harmful to human health lower in the atmosphere in the troposphere. It also leads to photochemical smog, something that we'll spend quite a bit of time learning about. And then again, it's a contributor to acid rain, just like sulfur dioxide is. So nitrogen dioxide, NO2, in the atmosphere converts into nitric acid, which then converts into nitrates, which eventually forms acid deposition or acid rain. Then we have carbon monoxide, and remember that carbon monoxide, CO, is very harmful to human health. So unlike carbon dioxide, which is not directly impactful to human health, carbon monoxide is. It is combusted when it's released, when pretty much anything is combusted. So fossil fuels, biomass, trash, wood, charcoal, etc. It forms during the incomplete combustion. So basically when these substances are not completely burned, especially in low oxygen conditions. Remember, it's lethal to humans and animals because it displaces oxygen in the bloodstream, and it's emitted in very high amounts by gas and diesel vehicles. In fact, car exhaust is the #1 source of carbon monoxide. Remember, it's also a very potent indoor air pollutant. So in developing countries that are relying on indoor biomass for cooking their meals, and for heating their homes, this becomes a really problematic issue for them. Next we have particulate matter, and particulate matter is a term we've used, but we want to unpack it a little bit further and make sure we fully understand it. So it just refers to solid or liquid particles that are suspended in air, and they are released when combusting fossil fuels, but most other matter as well, things like wood, animal waste, trash. It's important to know diesel fuel produces more particulate matter than standard gasoline, so think of that thick black smoke that comes from large trucks. Construction, cement making, the creation and use of roads, forest fires, volcanoes, dust storms, these are all other sources of particulate matter besides just combustion. Particulate matter is classified based on its size, so if it is larger than 10 micrometers, then it is not regulated by the EPA, and that's because nose hairs usually filtered out before it reaches our lungs, so we're less concerned about larger examples of particulate matter. Smaller particulate matter, especially that below 2.5 micrometers or PM 2.5, is the greatest concern to humans and animal health because it makes it all the way into our lungs and deposits in the respiratory tract. Particulate matter can also absorb incoming sunlight and limit the effectiveness of photosynthesis. So in high amounts, it can decrease plant function, and it contributes to something that we kind of refer to as haze, which is just reduced visibility due to all of this particulate matter in the atmosphere, and that's different than smog. So again, we'll be talking about smog shortly. Next we have lead. Lead is a naturally occurring element found in rocks, and it was formerly added to gasoline to improve vehicle function and also to paint. It's been phased out though in most developed nations starting in the 70s because there were relatively high emissions, so high atmospheric levels, and it's been linked to damage to the nervous system of humans and animals. This is especially harmful in older homes that have dust or paint that have lead in it from the previously additive to that paint. And so that's really harmful again to children because they're smaller and their developing nervous systems are not capable of handling that lead pollution. So it can be harmful to their brains, to their nervous systems, and it can lead to learning disabilities. And then finally we have primary and secondary pollutants. So primary pollutants are pollutants straight out of the smokestack or the exhaust pipe. They come directly from a source, things like carbon dioxide, carbon monoxide, SO2, NOx, particulate matter. Secondary pollutants, meanwhile, are primary pollutants that have undergone some form of transformation in the presence of sun, water, oxygen, or other compounds. So they've been released into the atmosphere and then they've been converted into something else. So an example is acid rain, where we have SO2 released from a little smokestack here, combines with water and oxygen in the air, we get sulfuric acid, and then acid rain.